Welcome to another LeetCode video. In this video, we'll solve valid anagram. Let's get started. So the goal of this problem is to check if two words are anagrams of each other. And what an anagram is that if you rearrange the letters of one word, it should equal to it'll have some combination that's equal to the other word. So in this case, we have anagram as our first word, and the other word is Nagaram. And if you or if you switch around some letters in this word, then it'll equal to this word. And in the second case, we have rat and car. So there's no possible way that rat can be rearranged to equal car. So we will return false. So there's like four different ways to solve this problem, and that's without the follow-up. So this will be important for later. We'll take into account follow-up questions later. For now, we'll just go over the four methods that we can use to solve this problem. The first method that we can use is just basic sorting. So if we sort our first word and our second word lexicographically, and we compare them to each other, then we should get the right answer. So if we call a sort on S and sort on T, and then you check if they're equal to each other, it should be true for this one and false for this one. But this method is not like very acceptable. I don't think any company or interviewer would accept that solution as your solution, because that's not that good of a way to do it. And the point of LeetCode is to like solve the algorithm part of it, so we'll be creating an algorithm. Also, this solution has a time complexity of n log n, which is not very efficient in terms of this problem. So let's go over some of the other solutions. So there's two different ways, or three different ways we can do it. All three of them are technically hash maps. One of them we can use an array instead of a hash map, but let's go over the first way we can use a hash map. So what we can do is we can count how many, or we can find the frequency of each letter inside of each word. So for the first letter word S, we have a hash map key value. So the key, let me write this. So the key in this case would be the character. So we'll have A, N, G, R, and M. And then in the value, we'll count each, like how many of each letter there are. So there's three A's in that one. There is one N, one G, one R, and one M. So we have the frequency of each character. And we're going to do the same thing for the other one. So we'll also have, in the other one, these are anagrams, so they'll have the exact same count. That's the approach of this solution. We'll find the counts of each character, and then we'll compare the count of each character and see if they're equal to each other. And we'll just return false if one of the values are not equal to each other. So this solution is O to the N. What happened? Let me put this back over here. So this solution has an O-N solution because we're only going over the words once. So where N is, actually it's not O to the N, it's O to the N plus N technically, because N is going to be the same size. So we'll have to check if, or let's go over like a basic check that we do. So the check that we need to do is if the length of this word is not the same as this one, then we can automatically return false, because you can't have an anagram with two different length words. So now we can just assume that n is the same length. So the time complexity is O to the N plus N, or this just turns into O of N. And the space complexity would be also O to the N, because technically it's O to the N plus N, so it's O to the 2N, because we're constructing two different hash maps of size N, so that becomes 2N. And that's the first approach. O to the 2N is not that optimized, so we can optimize this even more and we can create it in one hash map. So this is the third way. We have one map, and we're gonna go over the first word, and we're gonna find the same. We're gonna count the letters again, and this time we'll go over the second word, and we'll subtract one every time we see that letter. So let's construct our hash map again. Key value. So we have we have the characters as our keys. So we have three of A's in that word. Let's go N, G, R, and M. I think each of these appear once. So 3, 1, 1, 1. So those are the frequencies of each character inside the first word. This time we're gonna go over the second word, and we're gonna subtract 1 every time we see that letter. So we have 3 A's in the second word. So we're gonna subtract 3. We have 1 of everything else. And these are all gonna be equal to 0. So the approach for this is we're gonna do a check. If there is any number other than 0, then we'll just return false, because that's how we know that there's a different count of letters in each word. And if each number just is 0, that means it's an anagram, because we have the same counts for all the letters. And that's the second hash map solution. The last solution we can do is, instead of just using a hash map, we can construct an array of size 26, and we can use the ASCII values of a letter to add 1 to our count array. And this essentially does the same thing as the hash map. So basically, we're going over the first word, we're finding the ASCII value of each character, and we're going to insert it into this, or we're going to add 1 to the position in this count array. And for the second word, we'll do the same thing. We'll go over, find the ASCII value of each character, then we're going to subtract 1 inside this array. So if the word is an anagram, or if the 2 words are anagrams, this count array, all the letters should be equal to 0. If not, if something else is not 0, then we'll return false, because then we know that they're not anagrams. But this last array solution, it doesn't work for the follow-up, because it says if we contain Unicode characters, which means we'll have an array that's not size 26, because in this problem, it'll only contain English letters, but in the follow-up, it won't contain letters. It'll contain more. So in general, for this whole problem with the follow-up included, the hash map solutions are going to be the best way to do it. But if you don't want to count the follow-up, then this array solution is probably going to be the best way. So those last 2 solutions that we just went over, the time complexity is going to be O to the n, and the space complexity is going to be also O to the n. And now we got all 4 solutions. So let's go ahead and code them up. So let me go to LeetCode, and let's code this solution out. So the first solution that we said was the sorting solution. And we'll just return that. I'm not even going to submit this solution because it doesn't really matter. So I'm going to go straight to the second solution. So our second solution, what we said, we had 2 hash maps. So we had first, let's do our check actually. So if the length of one word is not equal to the other word, then we'll just return false, because as we know, 2 words that have different lengths, they cannot be anagrams. So we'll just have that check at the start. And we have to construct 2 different hash maps. So we'll have the map for the word S, and I'll default this to an integer hash map. And then we'll have the map for the other one. I can't type. And now we have our 2 maps. So we'll go over the characters in one of the words, or one of the words, and we'll insert it into the hash map. And we're just gonna add 1 to that character value. So then we can do the same thing for the other one. And we have, yep, it's essentially the same process. So now we have both of the hash maps constructed. So now we can just go over the values inside the hash map. So since we already did this check up here, we know that the lengths are going to be the same. So I'm just going to go over the length of the one of the words. And we can just say that if the, wait, let me think. So we have both in the maps. So we need to check if the value of, oh wait, this is not how you do it. We need to go over the characters in one of them. So we need to say if the value at that map is not equal to the value at the other map. And then if they're not equal, then we return false. And if it goes through the entire map without finding two different values, then we'll go through that whole loop and then we can just return true. Let's see if this works. There we go, and it works. And this is a good solution, but it's not the most optimized solution because we're constructing two hash maps instead of one. So this next solution will just combine all of this into one map, right? So let me just, we don't actually need to delete all of this. Let's delete that part. Let's keep one of these maps. So we're going to go over one of them and we're going to keep adding one to the, but the other one, we're going to subtract one. So if they're anagrams, then all the values inside each character in the hash map would be 0. So now we can, in here, we can just go through the values. Let me see how I construct this again. So, oh, we can just go over the number inside the values of the map. And if the count is not equal to 0, then we'll just return false. And else, or if it goes through the whole values inside this map and all of them are 0, then we'll return true because that's how we know that they're anagrams. So this should also work. Oh, I need to change this to map. And there we go. Now it also works. And the last solution that we did was with the array and the ASCII values. Remember that one's it won't work if you had the follow-up, but it's a one possible solution. So let's just go over that one too. So this approach is we need to construct an array of size 26. So I'll make them all zeros. And we're going to make it size 26. And for all the characters inside the first one, we're going to find the ASCII value of that character. So in Python, you just do this. So that'll return the ASCII value of the character C. And to insert it into this array, we need to subtract it by the ASCII value of the first letter in the alphabet, so A. So if we had, if C was the letter Z, the ASCII value for Z minus the ASCII value of A would be 26. Because, let me just pull up the ASCII chart actually. Wow. ASCII chart. Let's see where all the letters are. So, yeah, we have A to Z right here. So we have 90 minus, if the letter is Z, the ASCII value would be 90. And if we subtract it from the ASCII value of A, then it would be 90 minus 65, which is 25. And to access the 26 value in an array, we have to use 25. So yeah, that's how we access it. And if the ASCII value, or if this letter is A, and we subtracted it by a, it would just be 65 minus 65 equals 0. So that would be the first value in this array. And we're just going to add the count of 1 here again. So it's essentially the same thing as a hash map solution, but we're just going to be using an array instead. And we can just do the same thing for the other one, except this time we're going to subtract 1 instead of add. So it's essentially the same thing. We're just checking if all of these values are 0. So let's go through all the number. Oh, we can't do that. Let's do this. And if that number is not equal to 0, then we'll return false. Otherwise, if it goes through all the numbers and all of them are 0, then we know that they're an anagram, so we'll return true. And yep, this works also. So yeah, those are the 4 solutions for a valid anagram. I know this video is kind of long, but I just wanted to go through all the solutions so you know what to expect when you get asked this question or some kind of variety of this question. Hope you found this helpful. Thank you.